In this class, I will explain about two problems on Pitot tube, application of Bernoulli's theorem. In the last class, I had given the concept on principle and also the derivation of the velocity equation using a Pitot tube to measure the velocity of flowing pipes or channels. Then how to get the rate of flow or the discharge. So the first problem states like this. A Pitot tube was used to measure the flow of water in a pipe of 300 mm diameter. So diameter of the pipe is 300 mm. Water was raised to a height of 250 mm in the tube. So in the Pitot tube, when it is inserted at some point in the flow, in the pipe, the water level in that pipe has raised to a height of 250 mm. The static head at the center of the pipe is 200 mm. So 200 mm is the static head. So as I already told, you have two pressures there, static pressure and stagnation pressure. So static pressure will be the pressure at the center of the pipe, whereas stagnation pressure is the pressure at the entrance of the Pitot tube. Now the mean velocity is given as 78% of the maximum velocity. Taking the coefficient of Pitot tube or the coefficient of velocity as 0.98, determine the rate of flow or discharge in the pipe. So same figure I have drawn here, which I have used to do the derivation in the last lecture. So this is the pipe through which water is flowing. So I will take the discharge as Q here. Piezometer is inserted at one point and Pitot tube is inserted at another point. So the levels of water in these two tubes I have taken here and here. So the difference in the levels is h, small h. So this is, as I already told, this is nothing but your P1 by gamma. At section 1, whatever water rises in the piezometer tube, that elevation difference is P1 by gamma, that is the static pressure or the static head at 1. And similarly, at the point 2 Pitot tube is inserted and the elevation of water in this Pitot tube, so that is P2 by gamma, which is called as the stagnation head. Now in this problem, what are the given things we will write down? He has given that the static head at the center of the pipe is 200 mm. That means P1 by gamma is 200 mm, so which is 0.2 meter. We have to convert everything to meters. And P2 by gamma, stagnation head, he has given that it is 250 mm. So it has raised to a height of 250 mm. So that is 0.25 meter. Now the difference between these two is your h. I have explained that this difference P2 by gamma minus P1 by gamma is nothing but h. So h is given by 0.05 meter. So you have to take the difference between these two. Now diameter of the pipe 300 mm, that is 0.3 meter. Area of the pipe is pi d square by 4. You can get 0.0707 meter square. And mean velocity is taken as, is given as 78% of maximum velocity. So as I already told, maximum velocity is the velocity at the center of the pipe, which you are obtaining from the equation of Pitot tube, that is Vmax is equal to Cv into root 2 GH. So and he has given coefficient of Pitot tube as 0.98. Now only 3 steps are there as we did in the last problem. So first we will calculate the maximum velocity or the velocity here. So this itself is your Vmax. V1 is itself is your Vmax, center of the pipe. Cv into root 2 GH. Cv is 0.98 into root 2 into 9.81 into h is 5 centimeters, that is 0.05 meter. If you simplify this, you will get maximum velocity at the center of the pipe as 0.971 meter per second. So from the maximum velocity, get the mean velocity 0.78 times maximum velocity, 0.78 into 0.971. So you are going to get 0.757 meters per second. Now the discharge as the rate of flow can be obtained by using the equation cross section area of flow A into mean velocity, which is 0.0707 is the cross sectional area meter square into mean velocity is 0.757. So you will be getting 0.0535 meter cube per second. Please note that discharge will be in meter cube per second. That later on we can convert into liters per second just by multiplying by 1000. So because 1 meter cube is 1000 liters. Now we can keep it as it is. If you want, you can convert it into new liters per second by multiplied by 1000. So 53.5 liters per second is the discharge in the pipe, which is measured using the Pitot tube. So you can observe here that only by measuring this H, here, you can get the value of maximum velocity. From that mean velocity ratio, if you know, to get the mean velocity, then multiply that mean velocity by the area of flow, you are going to get the discharge. That is simple 3 steps. So in the second problem, see the data, diameter of the pipe once again 300 mm, static pressure he has given vacuum, so negative pressure. So it is in terms of mercury, 10 centimeters of mercury he has given. So why I have taken this is just to convert the pressure units. So last in venturimeter problem also I have taken such a case where at the throat section you have negative pressure. So here the negative pressure is there at the center of the pipe, P1 by gamma. So this is nothing but P1 by gamma. So P1 by gamma is your 10 centimeters. Next, the stagnation pressure at the center of the pipe, that is stagnation pressure is at the entrance of the Pitot tube, which is recorded as 98.1 kilopascal. See, they are different units. That's why I have taken this problem. When they are given, pressures are given in different units, you have to convert them into same units and then you have to apply the formula. And mean velocity is given 0.85% or 85% of 0.85 times Vmax or 85% of Vmax. CV once again 0.98. Find the rate of flow of water in the pipe. So water is flowing in the pipe. So what is the discharge? So discharge rate of flow is discharge. So once again, same 3 steps, these 3 steps, Vmax, Vmean and Q. Same formula, but only thing is pressure values you have to convert to same units. See how I have done this. So refer the same figure. So same figure you can use for this diagram also. Better you write the diagram in the examination. So write the diagram, then it is easy for you to write down the given data and use the respective formula for the analysis. So D is 300 mm, 0.3 meter, A will be once again pi d square by 4, 0.0707 meter square. Now see here, P1 is the static pressure, which is given as minus 10 centimeters of mercury. So that I will convert to in terms of water. Newton per meter square of water I have to convert. So it is minus 0.1 meters of mercury. So centimeter is converted to meter. Then that should be converted to meters of water. So I have to multiply by 13.6. Where 13.6 is nothing but the specific gravity of mercury. So this I have explained in the fluid pressure chapter also, how to convert pressure of one liquid in terms of pressure of another liquid. So multiply by 13.6 you will get in terms of meters of water. So afterwards the 0.1 into 13.6 is 1.36. So when this is actually in terms of pressure head, that if you want to convert it to pressure intensity, once again multiply that by the specific weight of water, which is 9810. That means this I am using P is equal to gamma H. So here H is this value 1.36, gamma is 9810 for water. We are going to get in Newton per meter square. If you do that, you will get minus 13,341.6 Newton per meter square. This is the value of P1. That is the static pressure. That means 10 centimeters of mercury vacuum pressure is the same as minus 13,341.6 Newton per meter square of water. Because the flowing liquid is water, better you convert in terms of water. So this is the value of P1. Now P2 he has given directly in kilopascal, 98.1, that is 98.1 into 1000, which comes out to be 98,100 Newton per meter square of water. So now this is also in terms of Newton per meter square of water. This is also in terms of Newton per meter square of water. So now you can use the formula. So this is P1 which is negative, this is P2 which is positive. So H value is as usual P2 minus P1 by gamma. So P2 is 98,100 plus P1, this minus into minus becomes plus here. 13,341.6 divided by 9,800 is gamma, because gamma is gamma W here. If you simplify that, you will get 2.36 meter as the H value, small h value. Once you get the H value, Vmax is given by CV into root 2GH. Substitute the value, CV has given 0.98. Even if they don't give the value of CV, you can assume. So you can assume the value of CV as 0.98. It's a standard value. So you will get 6.668 meters per second, and of course we need a mean velocity, which is a percentage of maximum velocity as given in this problem, 0.85 times. So 0.85 times 6.668 becomes 5.668 meters per second. That mean velocity is used to calculate the discharge. So A into V mean. So A is same area of pipe, that is the area of flow, 0.0707 into V mean is 5.668. You get 0.4 meter cube per second. So multiply by the 1000, you will get in liters per second. So 400 meters per second is the discharge. See, here only you should be careful about this stuff. How to convert the pressure of centimeters of mercury to Newton per meter square of water. So because if you want to find the value of H here, this P should be in same units and it should be in same liquid. So then divided by the gamma, if the liquid flowing here is water, so gamma W value we have to take.